Alright everyone, today we're going to be looking at mixtures. Now what we need to understand of mixtures is what they are. Now a mixture contains more than one substance, normally elements and compounds, or elements or compounds. So as it says, a mixture. So you get elements, you get compounds, you throw them in, you mix them. It's mixtures. Now an example of a mixture would be salt and water. But it's also a specific type of mixture. Alright, so salt and water is a common mixture. Now there are two main types of mixtures that are out there. Those are heterogeneous and homogeneous mixtures. So let's start with heterogeneous mixtures. Now heterogeneous mixtures, they possess different properties and compositions in various parts. The properties aren't uniform throughout the mixtures, right? So an example would be a mixture of sand and salt, right? So when you mix them, they don't have the same properties, right? They don't have the same composition. And when you mix them up, right, you notice that it's not uniformed throughout it. Now, homogeneous mixtures, on the other hand, homogeneous mixtures can be defined as mixtures that possess the same properties and combination throughout their mass. So, meaning that when you mix them together, they combined uniformly, right? So, homogeneous mixtures, they combine uniformly. You can't actually tell one apart from the other. In comparison to the heterogeneous mixtures, where because their properties and compositions are different, when they mix, they aren't uniform, meaning you can actually look and say, oh, this is a molecule of sand, this is a molecule of salt, because they aren't combined together and they're not uniform. While the homogeneous, they combine and they're uniformed, right? And because of that, you can tell one apart from the other. A good example for a homogeneous is sugar and water. Now, this is just a quick example of basically how it looks. So, if you look at the homogeneous aspect of mixtures, you notice that we have 1, 2, 3, 4, 5, 6 blue atoms. 1, 2, 3, 4, 5, 6 red atoms, and they're basically uniformed and in a particular pattern, so they're arranged uniformly in comparison to the heterogeneous that you have 1, 2, 3, 4, 5 blue, 1, 2, 3, 4, 5, 6, 7, 8, 9 red. So you notice they aren't uniformed. There isn't a balance in terms of the amount of them there. And also they are not combined. They're not basically together. And so you can actually look and tell them apart. So again, with the homogeneous mixtures, they are, one, have the same properties and combination throughout the mass for the homogeneous, and when they are combined together, you can't tell one apart from the other because they combine fully. In comparison to the heterogeneous mixtures, which they possess different properties and compositions, right, in various parts, and they aren't uniform throughout the mixture. Meaning, again, you can look and you say, oh, hey, this is a grain of sand, this is a grain of salt.